There was a really funny TikTok that was like about like the guy who invented the clock. You know what I'm talking about? And he's like, I came up with a way to, whatever, measure the clock. And he's like, all right, so what's it gonna be? And he's like, well, there's a big hand and a little hand. And he's like, okay, so the big hand measures the bigger increment of time. No. And then he's like, and then the second hand measures and they're like the second increment. And he's like, no, that's actually gonna be for a third hand in the middle. And then all right. So you guys took your test last class. So 4th and 6th aren't taking their test till today. So we're gonna open test corrections next week, which you guys know you don't have school Monday or Tuesday. So that would be Thursday after school if you anticipate that you probably didn't do well for voting days. So, but our next unit is going to be a little bit, I think, more like clear cut in terms of you don't have like a million rules. So we're going to do exponential functions. So the parent function is going to be y equals 2 to the x. Okay, where 2 is the base and x is like in the exponent, so it's like a superscript. Okay. So here's what the graph looks like. First thing I want you to do is draw in a horizontal asymptote at y equals 0. Your graph will never touch 0. So I'm going to put here HA y equals 0. Okay, and remember that for a horizontal asymptote, that's a line your graph gets closer and closer and closer to at the end of the graph, but it doesn't cross. Now, because I can't touch 0, most parent functions go through the origin. Okay, this one can't though, because it can't touch that line. So you're going to put your dot right here at 1. Your next dot is going to go at 2. Then you're going to times 2 again. What's 2 times 2? Next dot goes at 4. And then can you times by 2 one more time? What's 4 times another 2? Your next dot is 8. Now, your next dot after that would be 8 times 2, which would be 16 way up here. Okay, so I'm not going to have you draw past that, but what you notice is that your graph is going to grow faster and faster and faster as you double to get those y values. On the left-hand side, it's going to get closer and closer and closer to 0. Okay, this is called exponential growth. Okay, and you actually did see this in Algebra 1 and probably also Algebra 2, but I know geometry, you didn't see it, so it's been a while. Okay, but exponential growth is where your graph is growing faster and faster and faster and faster. So this side gets really, really steep. This side is going to flatten out towards your 0. Okay, the domain and range for this, let's do domain first. How far to the left does this graph go? We have a little arrow there. Okay, and how about to the right? Yeah, so my domain is going to be negative infinity to infinity, or if you remember that symbol, all real numbers. Okay, because my graph goes to the left forever and to the right forever. However, for range, remember range is lowest to highest. My graph can only go how low? 0. It can't go past 0 because remember, it can't cross that line. So my lowest is going to be 0. And then my highest is still going to be infinity because my graph is going up forever. Now, normally on numbers, we give a bracket. And what that means is that you get to that number. But because I get closer and closer and closer to 0, but I can't touch it, I'm going to do a parentheses on both sides. So I can't get to infinity. I also can't get to 0. So we do parentheses on both sides. Okay, now the good news about this parent function is it follows all the same rules as all the other parent functions that we've done all year long. So take a look at number 1. Do you notice that up with the x, there's a little -3? Which way does the number with the x shift the graph? Left, right, up, down, if it's a -3. To the right, very good. What about a +5 in the back? Which way is that gonna shift it? Up 5. So go to the right 3 and up 5. 1, 2, 3, 1, 2, 3, 4, 5. And in that dot, you're gonna draw your new horizontal asymptote. So now I cannot touch what Y value? 5. Now notice the 3 kind of moves side to side, but it doesn't actually affect where the asymptote goes. So Y equals 5 is now the HA that my graph cannot touch. Okay, from there, we're just sketching the parent graph. Your center dot always starts, if you look back up at your original, 1 box above the origin. So your dot needs to start 1 box above the origin. Okay, and then if you remember, the next dot went 2 above and then 4 above, but we're just gonna sketch the shape. It's gonna go here and then here. Okay, you're drawing the exponential growth graph. Looking at my left and right, what's my domain gonna be? How far to the left, how far to the right? All reals, very good. And then for my range, what's the lowest that this graph can go before it gets stuck? 5. So it'll be 5 to infinity, where 5 is the lowest it can go, infinity is the highest. Okay, but notice that we're giving 5 a parentheses because it can't actually cross 5. It gets closer and closer, but never gets there. Okay, take a look at number 2. What is the shift gonna be on number 2? If I have a -4 up top, left, right, up or down? To the right, and then the -6 would be down 6. So go to the right 4 and down 6. That would be right here. And then remember, through that dot, I'm gonna draw my asymptote. That's the line your graph cannot cross. So it'd be right here. For my HA, I'm gonna put Y equals -6. Remember, that's the line that my graph cannot ever get to. Then remember, your starter point is gonna be exactly 1 box above the center, as long as there's no stretch or compression. Does this one have a number in the stretch or compression spot? Yes. See this 3 right here? The number in the front is going to do a vertical stretch or compression. Because 3 is bigger than 1, we're going to call it a vertical stretch. And so instead of placing my dot 1 box above the new center, I'm going to place it 3 boxes above the new center. So 1, 2, 3. And then remember, it's going to go down towards the line on this side and then up on that side. Okay, but this is your exponential growth function. Can someone tell me the domain? All reals. And then for the range, what's my newest low value on this one? So it'd be -6 till infinity. Remember, parentheses on the -6. Yes, sir. Okay, as soon as we're finished, you should have time to do both. Last one. Which way are we shifting it? Right. +5 means we'll go to the left and down. So go left 5, down 1. Drawing your line. Okay, then normally I start my first dot 1 box above where that new sort of center is. How far up will this dot go this time? Okay, a half of a box. Very good. So I'm going to write vertical compression. And I'm going to put my dot kind of halfway through in the middle here. Okay. And then remember, it's going to go up to the right, down to the left. Y equals -1 is your HA. domain is all real numbers, and it'd be -1 to infinity for your range. Okay. Any questions on that kind of situation? Okay, so rather than doing your notes in 2 halves, since this part was super short, we're gonna just go into solving. So if you'll take a look at the next page, please. Okay, for the next page, we're gonna learn how to solve equations that are exponentials using a method called the common base method. So you'll see at the top, okay, that I gave you just a whole bunch of powers, because I know for some people, the multiplication tables are a bit of a struggle. But here's how these charts came about. Let's do the 2's. What is 2 times 2? Times 1 more 2 would make it 2 cubed. That turns it into an 8. If I times by 1 more 2, that would make it 2 to the 4th power. That gives me 16. So remember that if I'm looking at, let's say here's 3 to the 4, that means it's 3 times 3 times 3 times 3. So you can do this in your head if you want, but the chart's there if you need. Okay, here are your steps. You are going to write each side in terms of a common base. Okay, because remember, this is called the common base method. After you rewrite each side in terms of a common base, you are going to set the exponents equal to each other. Basically, that means you're going to cancel the common base. Okay, and then in step 3, you're going to solve. So let's take a look at number 1. Okay, I have 2 to the 2x equals 64. Here's what you're going to do. You're going to take your 64 and you're going to convert it into a base 2. So can you look in your 2's chart? Okay, that's this one. And tell me, what power would 2 have to have on it to equal 64? 2 to the 6. Very good, right here. So here's what you're going to do. You're going to do 2 to the 2x equals 2 to the 6. You're going to convert it so that both sides have the same big number as the base. Once you have that, you can cross the base out. As long as you're doing the same thing on both sides, okay, you can continue solving. So now I have 2x equals 6. What would my next step be after that? Divide by 2 on both sides, and x would equal what? 30. Okay, let's do another one. Let's do number 3. Okay, you always pretty much are going to want to take, if it's a big base, you want to drop it to match the little base. So look in your 5's chart. We're looking to turn 25 into a base 5. You always want to take the bigger number and find it in the little numbers chart. So look at your 5's chart. Do you see 25 in there? Yeah, 5 to the 2, right? So I'm going to come right here where my 25 is. I'm going to make it a 5 to the 2. And then whatever exponent was already there, you're just going to like group it in parentheses. So if my x minus 3 was here first, it's still going to be there, but I'm going to kind of group it off to the side. Okay, then for my 5 to the 10, I can leave that alone because it already had the base 5 that I want. Then what do? Cross out the 5s. Very good. So now what's left is 2 times x minus 3 equals 10. Now, maybe I'll go ahead and do this all in one step, but these are multiplied. So you're going to times that 2 into both terms. So it's going to be 2 times x is 2x. What about 2 times minus 3? Minus 6. Very good. Equals 10. Okay, then from there, what's my next step to solve for x? Add the 6 across. Very good. That's right. 10 plus 6 is going to give me 2x equals 16. And then last step, what do I do with that 2 in the front? Divide to get rid of it. Very good. 16 divided by 2, that's going to give us 8. All right, next one, let's do number 4. Okay, look at your bases. One side, it's a 216. The other side, it's just a 6. Remember, you want the big to match the little. So look in your 6's chart for me. Do you see 216 in the 6's chart? 6 to the what? 6 to the power of 3. Very good. So it's going to be 6 to the power of 3. Remember, any old exponent you're going to keep, but you're going to just put it in parentheses. So if I already had an x here, I'm going to keep my x there. And then on this side, I have 6 to the x minus 4. Okay, from there, once I have the big matching 6's, I can cross those out, set the exponents equal to each other. So my 6's are gone. And then remember, the 3 and the x, these are being multiplied. If they're both exponents, they're going to times together. So 3 times x is a 3x, x minus 4. Next step, I have x's on both sides. Okay, typically I'm going to move whatever x is on this side over to the left side. So if this is a 1x, I'm going to do a minus 1x and a minus 1x. What's 3x take away 1x? Okay, 2x. And if 2x equals negative 4, what's my next step after that? Divide by 2. Negative 4 divided by 2 is negative. Okay, one more left like that. Take a look at number 6. Okay, look at your bases. I have 125 on one side. I have 5 on the other. So what chart am I looking at? 5s, and I'm looking for 125 in that chart. So do we see it? 5 to the 3, very good. So 125 is going to go 5 to the 3. Old exponent stays grouped. So it's going to be an x minus 2 equals. And then on your 5 side, if you notice, you don't have a power. Okay, if it's just a 5, that's 5 to the 1, meaning you have 1 5. So if a power is missing, you can use a 1 for that. Okay, then from there, we're going to cross the 5s out and solve it. So it'll be 3 times x minus 2 equals 1. 3 times x is a 3x. What's 3 times minus 2? Minus 6. And then equals 1. From there, how do we get rid of the minus 6? Add it. 1 plus 6 is going to give me 3x equals 7. And then last step, divide that 3 across. Okay, some of your answers on your assignment today will come out to be fractions. Okay, do not put it in. 7 divided by 3 is like 2.333. Don't put that in. Keep it as a fraction if it doesn't divide evenly. Okay? All right, turn the page. Let's look at some specific situations. We're going to start off, please, with number, let's do number 10. Okay, so first thing I want you to do on number 10 is notice that your base is what number? What chart should we be looking at? The 4's chart, very good. And then what's the number that we're looking for in the 4's chart? 64, very good. So flip back your paper if you need to. What is 64 in the 4's chart? 4 to the power of 3, very good. So here's what we have. 4x minus 1, all of that squared, equals 1 over 4 to the power of 3. Now, we have a little bit of a problem. I have a 4 here, and I have a 4 here, and normally I can just cross those out. But this 4 is in the bottom of a fraction. Do you notice that? So the way that you're going to pull that 4 up from the bottom of the fraction is you're going to take the 3 and turn it into a negative 3. So write a little memo in your notes here that if you want to pull the 4 to the 3 up, you can move to the top if you use a negative exponent. So instead of it being a 4 to the 3, If I write it as a 4 to the negative 3, then now I can pull it up, cross the 4s out on both sides. Okay. So from here, I now have both regular 4s. I can cross them out. And then when this 4 is gone on this side, I want you to notice this 2 will still have to times by both of these guys. So 2 times x will be 2x, thank you. And then 2 times minus 1 will be minus 2, equal to negative 3. What's my next step to solve? Add the 2 across. Negative 3 plus 2 is going to give me 2x equal to negative 1. Then divide that 2 across and we'll get what for our answer? Yeah, negative 1 over 2 or negative 1/2. Okay, now if you divide negative 1 by 2 and you get negative 0.5, you could type that in as the answer. What you don't want to do is if it's like 0.555632, that's where you would not want to switch it to a decimal. Okay, but I would just do fractions all the time. Okay, let's do maybe 2 more that are fractions, or maybe just 1 more. Let's do number 12. Okay, my big number needs to be looked up in my little numbers chart. So this is a 49. I'm looking it up in the 7s chart. What is 49 as a power of 7? 7 squared, very good. So I have 7x minus 1 to the 4th equals 1 over 7 squared. But because the 7 squared is in the bottom, and I really need to pull it up to the top, what am I going to use in my exponent? Very good. So I'm going to use negative because fraction. Okay, that's not a real sentence, but just pretend. Okay, use a negative because it's in a fraction. So now you have this 7x minus 1 to the 4, 7 to the minus, or negative squared. Then from there, cross your 7s out. Go ahead and solve that for me. So my 7s are gone. And then remember, on that left-hand side, that 4 needs to multiply into both. So it'll be a 4x and then a minus 4 equal to negative 2. Add your 4 across. In your calculator, what is negative 2 plus 4? 2. And then divide the 4 across. You get x equals 2 over 4 is the same as 1/2. Okay. There are a lot more examples, but we kind of feel like we get the idea. So if it's a fraction, just use a negative in your exponent and you're good. Okay, last question we need to go over on this page is number 7. Okay, what if the other side of your equation is a 1? So come up to number 7. Okay, there is a special property, okay, about any base to the 0 always equals the same number. So in your calculator, type in whatever number you want and then put it up to the 0. Okay, so I'm going to type in whatever up to the 0. What is it always going to come out to be? 1. That's a special rule about 0 in the exponent, is it always gives you 1. Okay, you can type in whatever number you want. If you put it up to the 0, it's always going to give you 1. So knowing that that's the case, okay, go ahead and fill in any base to the 0 is always 1. If I need my equation to equal 1, that means I can use whatever base I want as long as I put a 0 up top. So on this side, see how it's a 9 to the x minus 6? Then I'm going to use 9 to the 0 on the other side. Because remember, 9 to the 0 or any number, as long as there's a 0 up top, is always going to equal back to 1. And remember, the reason I need those 9s to match is so I can cross them out on both sides. So eliminate your 9 here and here. Now we have x minus 6 equals 0. And then we're just going to add that 6 across to solve. So plus 6 plus 6. Get the idea? Okay, we have to do one more type of question and then we're done. So turn the page. Take a look for me, please, at number 13. Okay, number 13 says 9 to the x plus 3 equals 27 squared. I want you to look in your nines chart for 27. Nines chart for 27. Is it in there? Okay, no, it's not. Look, here's my nines chart. Okay, the smallest 9 I have in the nines chart is 81. So we missed it by a long shot. So I want you to look in the other charts and see if you can find a chart that both 9 and 27 can both be in. Okay, the 3s, very good. 9 is 3 what? Squared. 27 is 3 what? Cubed. So if you can't just make them, the big one match the little, you may have to switch both of them to a smaller base where they are both compatible. So let's do that in your notes on that question. Okay, so we're gonna lower, if they're non-compatible bases, you're gonna lower both bases to find the least common base, meaning something that they can both match it. So 9 goes to 3 squared, old exponent stays grouped. And 27 is gonna go to 3 cubed, old exponent stays grouped. Then from there, we're gonna cross those 3's out, keep solving. So my 3 here and here are gone. Let's times that 2 in. So 2 times x is now a 2x. 2 times plus 3 is a plus 6. And then remember, on this other side, if they're both exponents, you're multiplying. So that's 3 times 2 gives me 6. Next step, what do we need to do? Subtract the 6. And 6 minus 6 gives me how many? 0. Now remember, 0 is a number, 0 could be an answer. So my next step, I go to divide the 2. And what is 0 divided by 2 still? Still 0. Okay, and you should get at least probably one question, I think, in your homework where 0 comes out to be the answer. That's okay. All right, last question we're gonna do, let's do number 15. Last one for today. Okay, look in your forest chart and see if 32 ever appears in the forest chart. Okay, no. So then we need to find a smaller base that 4 and 32 can both be in. 2 is very good. So if I look right here, 4 is going to be 2 squared, and 32 is going to be 2 to the 5. So we're going to have to go back to a power of 2. So my 4 is going to go to 2 squared. Old exponent stays behind. And then 32 is 2 to the 5. Old exponent stays behind. Okay, remember, you want to keep them in parentheses so that you remember to multiply once those bases cross out. 2's gone, 2's gone. 2 times x is 2x. 5 times x is 5x minus, what is 5 times 8? 40, very good. Okay, from here, you've got x's on both sides of the railroad tracks. Okay, I'm usually gonna try to pull whatever one's on this side over to that side. So if my 5x is positive, how do I undo it? Subtract it. So 5x minus 5x crosses out, I have a negative 40. And then what is 2x take away 5x? Very good, negative 3x. Then last step, divide that negative 3 across. For your delta math, if you type it in like this, it is going to count it wrong because what can cancel? A negative divided by another negative, how's that come out? Positive. So it should be a positive 40 over 30, or 40 over 30. Okay? The questions like these bottom two, I took those off of your homework, since fourth and sixth have to do this notes for homework. Okay? All right, pull out your Chromebooks, yes? Sure. And then Jared, you're ready to start your test? It was the bottom and the top is exactly one bigger. Remember that. And the way that you find it. Remember, you don't actually need the remainder. And then if you have a situation, some of them. Revert to us and remember, you can. You have to. Fourth and sixth will have to take it today, so I'd say copy by Friday. But I'm hoping to grade them all those classes. So maybe sooner, but. Oh, is it hidden thing? My bad, y'all. I think your homework is not viewable yet.